Hello, happy Friday. So today I'm going to start off our discussion with some apps I found useful that are free. I'm going to ask you guys to add to that Google form for today any tools or applications that you've found or have been using that are free and have helped you out these last few weeks. And that way I can share them with the whole class so that we have some tools that we could use as we move forward. Okay, so the two apps I'm going to talk about are completely unrelated to each other, but the first app that I've used a lot in the past and is now free, so premium is free, is called Down Dog. So a few of us have probably heard me talk about this before. Basically, you can pick a type of sequence. There's even a new one that is based on chair exercises only. So if you're like me and not used to sitting or don't like sitting at a desk or chair all day, there's a sequence that's called chair poses that you can do entirely from your chair without moving at all. So even if you just try one of those sequences out for 5 minutes, could give you a nice break in between your virtual classes. So you pick the sequence type, the level, the length. It could be as short as 10 minutes or as long as an hour and a half. And you get to pick your music playlist as well. After the session, you can go back and take a look at your playlist. This has actually helped me find new music too. So that could be interesting as well. Okay, so it's free for the next month. Premium's free, so you get all the advanced features for free. But there is a free version of the app normally, which I've been using for a few years now. It's been helpful. The app is called Down Dog, and the app symbol is on the bottom right-hand corner. It's a puppy face. The other app that I've been using is a free scanner. So you can scan things like receipts or your textbook problems that you've written down on notebook paper, labs. You can scan multiple pages and it will create one condensed PDF document so that it's easier to upload to Google Classroom or via email. So instead of having like 5 pictures for each page, it creates one PDF directly from your phone. You can scan black and white, color. So if you're in art or you're taking a design class, you can take pictures as well. It'll create a PDF for you to attach to Classroom, colored images. And that's called Genius Scanner. Genius Scanner. And that's the app picture will be an orange circle type image. So Genius Scan. Okay. So again, if you have any suggestions of free apps or even strategies or resources you've been using the last 2 weeks that you think other students would find helpful, you're going to add that to the Google form that's posted in Classroom. So before we get started today, talking about the frequency of a pendulum, we're going to recap some formulas that you should have on your note card. If you don't have these formulas on your note card, you should pause the video and add them right now under the title SHM, which is an abbreviation for simple harmonic motion. Okay, so the equations that we have, the first one there, capital T is for period. Okay, and period is 1 over the frequency. We also know that frequency is 1 divided by the period. Right? They are inversely proportional. Frequency is measured in hertz. Capital H, lowercase z is the abbreviation. Period is measured in seconds. Okay, specifically the period of a pendulum, capital T, is equal to 2 pi times the square root of L divided by G, where L is length in meters and G is the acceleration due to gravity in meters per second squared. So again, please make sure that these equations are on your note card. We're going to derive an equation for the frequency of a pendulum using this set of equations that we have here. Okay, so let's say we have our equation for frequency in terms of period. So frequency is 1 over the period. The period of a pendulum we know is 2 pi times the square root of L over G. We're going to take that equation and substitute in T. So we're going to take that quantity, 2 pi times the square root of L over G, and we're going to plug that into the denominator. Okay, that looks messy, right? So to get that out of the denominator, we're going to multiply top and bottom by the reciprocal. When we do that, we get the equation that the frequency of a pendulum is equal to 1 over 2 pi times the square root of G over L, where G is the acceleration due to gravity in meters per second squared, L is the length of the pendulum in meters, and lowercase f is the frequency of the pendulum in hertz. That is our new and our fourth equation that should also be added to your note card. Okay, so now that we have an equation that's specifically in terms of frequency, it's going to make solving for frequency of a pendulum much simpler. So let's take a look at an example. Okay, so example 2. A 10-gram mass is attached to a string. It is pulled at an angle of 10 degrees and released to swing as a pendulum. If the pendulum is located on Earth's surface and the string is 0.4 meters long, find the frequency of oscillation. Okay, so we know that we're looking for frequency. We're given the length, which is 0.4 meters, G, which is the acceleration due to gravity, 9.8 meters per second squared. The amplitude, which we use capital A to represent, is 10 degrees, and mass is 10 grams. We actually do not need the mass or the amplitude at all. Those values are given to you most likely to throw you off. So we can actually ignore those two pieces of information. The first sentence is basically useless. Okay, the second sentence is what we're focused on. The pendulum is located on Earth's surface and the length of the string is 0.4. Find the frequency. So you write down the equation for the frequency of a pendulum, 1 over 2 pi times the square root of G over L, and we're going to plug in what we know. So we're looking for frequency, we leave that as a variable. We know that G is 9.8 and that the length is 0.4 meters. Okay, so order of operations, you must take 9.8 and divide by 0.4, and then take the square root. We see here we have meters per second squared divided by meters. The meters will cancel out, and we'll have the square root of 24.5. The units are 1 over seconds squared. 1 over seconds squared simplifies to which unit? hopefully remember from Monday, right, that 1/2 squared is equal to a hertz. So we're going to take the square root of 24.5. We will get 4.9497, and our units are hertz. We still have that expression 1/2 times pi. Technically, right, that statement is equivalent to taking 4.9497 and dividing by the quantity 2 times pi. So in your calculator, right, you're taking that answer 4.94974 and you're dividing by parenthesis 2 times pi close parentheses. Okay, so please make sure that you include that when you type that into your calculator. Please test it out and make sure you get the right answer. If you do not, send me an email and I will explain or work with you to kind of determine based on your calculator how you should be typing it. So this should work for you. The value you should get is 0.79 hertz. Okay. So for practice, a good idea would be to determine the period. So now that we've found the frequency, find the period of a pendulum. So pause the video and give that a try. Find the period of a pendulum. Okay, so if we're looking for a period and we have the frequency, the easiest way to do this would be to take advantage of the fact that period and frequency are inversely proportional. So we take 1, we divide by 0.79 hertz. Hertz are equivalent to 1/2 seconds. So technically here we have 1/1/2 seconds. To clean that up, we'd multiply top and bottom by the reciprocal, seconds over 1, and the units we get would be seconds. So the period is 1.27 seconds. Okay, so that's it for today. 2 things. You must mandatory fill out that Google form in classroom. It counts as attendance. Okay, and the link to the Kahoot that we played in class on Wednesday is also in classroom. So feel free to play independently, okay, or to set up a challenge. Okay, if you have any questions, you know what to do. Have a great weekend, and I will talk to you guys on Monday.